differential equation is a relationship between an independent variable, say x, and a dependent variable, say y, and one or more differential coefficients of y with respect to x. For example, x squared dy by dx plus y sine of x equals 0. And another example is xy d2y by dx2 plus y dy by dx plus e to the power 3x equals 0. So in this first example, we can see that this equation contains a derivative, this one. In the second example, we can see two derivatives, one in this term and one in this term. In this first example, we can only see the first order derivative of y with respect to x, while in the second example, we can see a second order derivative of y with respect to x. So a differential equation actually represents dynamical relationship. It means quantities that change and are thus frequently occurring in scientific and engineering problems. The order of a differential equation is given by the highest derivative involved in that equation. For example, the order in this equation is 1 because the highest derivative is of the first order. The order of this differential equation is 2. It is second order differential equation because the highest derivative occurring in this differential equation is of the second order. How a differential equation is formed? This is yet another interesting question. So next we focus on how to form a differential equation. And remember, in this session, not only in this session, but in the next few videos, we'll be just focusing on the first order differential equations and their solution techniques. So a differential equation can be formed in practice from a consideration of the physical problem to which they refer. Mathematically speaking, they can occur when arbitrary constants, I repeat this word, arbitrary constants are eliminated from a given function. Here are a few examples. With the help of these examples, we'll try to understand what I actually mean by elimination of the arbitrary constants and the order of the differential equation. So, as a first example, this is the first example. Consider there's a function y equals a sine x plus b cos x, where this a and b are arbitrary constants. Now, if we differentiate, we get dy by dx, what we obtain. Differentiating this term, this will become a cos x, because derivative of the sine x is always cos x. And when we differentiate this one, the derivative of the cos x is always Yes, you are right. It's minus sine x. So this will be minus b sine x. Differentiating one more time, that is d2y over dx2 gives us minus a, because now when we differentiate this cos, its derivative will be minus sine x. So minus a sine x, and this will be same thing, minus b cos x. Well, now take this equation and just try to recognize something familiar with this one. What do we see? A sine x, a sine x, b cos x, b cos x, with the exception that both the term in here are negative, minus a sine x, minus b cos x, while in the original function it is plus, plus a sine x plus b cos x. It means that we can write this one like this: d2y over dx2 equals minus a sine x plus b cos x. And what is this? Isn't it this original function? Yeah, it is. So we can replace this one with minus y in here. Now this d2y over dx2 is equal to minus y. Yes, you are right. And after a slight shuffling, we can write the equation like this: d2y over dx2 plus y equals 0. So a differential equation is formed, and you can see that this is actually, let me border it with this orange color. I hope so it will be visible in the video. Okay, so what we see, that after eliminating those two arbitrary constants, we ended up at a second order differential equation. The original equation was like this, you can see, and here you can see two arbitrary constants a and b, and the result is a second order differential equation. Let's do another example and the matter will be much clearer then. So we now move on to another example, example 2. In here we are told to form a differential equation out of an equation, and the equation is y is equal to x plus a by x. Let's try it and let's see what is the result, what differential equation is formed. Well, after some changes, we can bring it to some more plausible form, that is y is equal to x plus a x inverse. This is plus sign, sorry. Now differentiating it with respect to x, this gives us dy by dx equals what? The derivative of this is simply 1 what next? Here the derivative will be minus a, and x minus 1 will be minus 2, x minus square. Okay, the result can be written as 1 minus a by x squared. It's the same as this expression. Well, from the given equation, we can see that a by x from this one. From this given equation, we can write a by x equals y minus x. Pause our video in here and just try to obtain this from this one. You will be able to easily to do this. Well, it means that we can write, it implies that a is equal to x to y minus x. Yeah, it can be written like this as well. Now I'm moving on to next page. Okay, so let's continue with the problem. We obtained, I rewrite again, a is equal to x into y minus x. It means that dy by dx now is 1 minus x y minus x over x squared. What I simply did, if you remember, here in the numerator was a, this one. So the rest of the equation is the same. I just replaced a with this expression on the right hand side. So we end up with this expression in this equation. Well, we now proceed like this. You will see in here this x, well, we cancel with 1x in the denominator, and the result is 1 minus y minus x over x, which is the same as x minus y plus x over x. What I did in here, I just took the LCM, and the result is this one. This is quite simple mathematics. You can easily do this. And this will result in 2x minus y over x by adding up these two x's, and this result, and the rest of the terms are the same. Therefore, what we conclude now, what we arrive at, we arrive at that x dy by dx equals 2x minus y. Remember, this is dy by dx, and this x was simply shuffled to this left hand side, so this expression is the result, and the rest on the right hand side is the same. What we see? We see another differential equation, but just by looking at this one, you can easily recognize that this is a first order differential equation. Yeah, because the highest derivative involved in this differential equation is this first derivative of y with respect to x. So the original equation contained just one arbitrary constant, and when we tried to obtain a differential equation out of that, what we ended up at, the result is a first order differential equation. So now we can generalize something. Yes, a very interesting result in the literature of the differential equation. And what is the generalization? It is a function with one arbitrary constant. Constant gives, yes, first order differential equation. A function with two arbitrary constants give second order differential equation, and so on. So hope that by these examples you would have picked the concept, what are first order differential equations and how they are formed. Now here are a few examples. Let's first get to know what are these examples are. So the first one is y is equal to e minus 2x into a plus bx. This is the first example. The second one is y equals a into x minus 1 over x plus 1. The third one says that y equals e to the power 3x into a cos 3x plus b, sorry, this is plus b sine 3x. Okay. Now, without working each out in detail, we can say that this one is, yes, you are right. This one is second, this would give off a second order differential equation because this equation contains two arbitrary constants. So the resultant equation, the differential equation, would be second order. Here, just by looking at this equation, you can readily recognize that the resulting differential equation will be first order because only one arbitrary constant is involved. So it will be first order differential equation. And what about this one? Yes, here we can see two arbitrary constants, right? So the resulting differential equation would be of the order 2, yes, second order differential equation. We now turn on our attention towards the solution of the differential equations. So how a differential equation is solved. Solutions of differential equations. Well, to solve a differential equation, we have to find the function for which the equation is true. This means that we have to manipulate the equation so as to eliminate all the differential coefficients and leave a relationship between y and x. So just simply saying that by finding a simple relation between y and x between the dependent and independent variable is actually the solution of that differential equation. There are many techniques. As far as the first order differential equations are concerned, there are a few simple techniques. We begin with the simplest one and then we'll go on. The first of these techniques is by direct integration. So the first technique is the method 1. Method 1. Yeah, it is by direct integration. Well, how it works? Let's do it with the help of some examples. For example, if we are given a differential equation like this, gy by gx equals 3x squared minus 6x plus 5, and we are told to find its solution. So by looking at the right hand side, we can readily recognize that this can be done with just simple initial integration. Before proceeding on with this differential equation, let me have a sip tea from my cup. Wow, the tea is fantastic. Yeah. Well, so just applying the simple integration techniques, this will be y is equal to integral of 3x squared minus 6x plus 5 and dx, because this whole integration process will be carried out with respect to this differential dx. Well, it's quite easy. Y is equal to x cubed by simply integrating this one minus, well, it will be x squared by 2, and this will be 3x squared and plus 5x plus c, some arbitrary constant. Well, what we see, we have an original equation, a relation between x and y, and in this equation, this original function, we can see only one arbitrary constant, c. Hence the result. You can easily recognize that by eliminating this one arbitrary constant, you will be able to find this first order differential equation. Here is another example. Let's do it, but let me do it on the next page. Yes. And another example, we are told to solve x dy by dx equals 5x cubed plus 4. Okay, so here is the solution. This is the solution. We can write it like this: gy by dx equals 5x squared plus 4 by x, because we divided the whole equation by the x just to get rid of the x in here on the left hand side. Well, now it is a straightforward matter of just simple integration process. So y will be now the integral of 5x squared plus 4 by x and dx. Now y will be simply 5x cubed by 3, yes, you're absolutely right, plus 4, and this is actually 1 over x. So what will be the integral? The natural log of x plus c. Very well. You have found the solution quite easily and quite quickly. Now, here is an example, yet another example, but this time I'm not going to solve it for you. This is just your homework. Have your cup of tea or coffee, enjoy your cup of tea along with this equation. So here is the problem for you. And what is the problem? Find a solution for Ex dy by dx equals 4. Yes, you have to find the solution. This is not as simple as these previous examples, but let's try it. If you are able to do this, that's very good. If not, I'll be making another video on this one for you very soon.